Hi, just a quick one on found this on a website, criticalthinking.org.uk, written by a PhD. What is pseudoscience? Before we start, fair use and all that for educational purposes, just to show people and so people can learn what pseudoscience is. A theory, methodology, or practice that purports to be scientific yet is without scientific foundation. Pseudosciences are practices that masquerade themselves as science but have little or no scientific rigour or cohesion to them. They claim to be factual and scientific yet do not adhere to scientific methodology and principles, notably the scientific principle of falsifiability. It can be difficult for the non-scientist to discern whether something being claimed as scientific actually is or not. Fortunately, pseudoscience has many recognisable features that are distinct from genuine science. These features are outlined below. Whilst not every feature will be common to every form of pseudoscience, any claimed scientific practice that displays at least some of these features is increasingly likely to be pseudoscientific. It's dogmatic. A dogmatic belief or position is one that is deemed by its proponents to be accepted authority, and as such not to be doubted or disputed. The heliocentric model. They're deeming it to be accepted authority and it can't be doubted or disputed. There we go, you see. Pseudosciences tend to have evolved very little or not at all. Maybe we've got as gravity. It's evolved very little or not at all since it was first established. Any research or experimentation that is carried out in the field is generally done more to justify the belief than to improve knowledge. In science, observations are made, a hypothesis is formed, data are gathered, and testing is done. And if the results of testing supports the hypothesis, a theory, see provisional conclusion, but they've changed the meaning of the word. We'll get to that in a minute. Is formulated. If any evidence comes to light that invalidates the conclusion will be amended or even rejected, and a replacement theory sought. I tell you what, instead of the word theory from now, I'm just going to use the word idea. In pseudoscience, they begin with a solid conclusion, such as homeopathy works, form theories as to why it works, collect data that support the conclusion, and reject or explain away data that doesn't, which inevitably results in the conclusion being confirmed. With this system, no evidence is capable of contradicting the conclusion. Well, didn't Einstein do that? He turned around and says, there is an ether and it'd be stupid to say there wasn't. Then the Michelson-Morley experiment was done, where they bounced a laser off the ether to prove that the Earth was spinning. It failed, because it showed that the Earth wasn't spinning. And Einstein came out with the theories of relativity and said, well, there is no ether. So he explained stuff away, because it didn't fit. Challenging the accepted dogma is often considered a hostile act. There we go. We're challenging the accepted dogma of the heliocentric model, gravity, all that sort of stuff, and they're considering it a hostile act. We see that constantly, not just with the public and people at large, but with the scientific community as well, and the mainstream and everything else. Well, and such challenges will be fought off with attacks on the critic's character. We get that a hell of a lot. Or motives. We get that a hell of a lot as well. Rather than embraced as a way of testing claims as in real science. As a consequence, the same arguments and counter-arguments are seen time and again. We see that a lot as well. Scientists give reasons why the practice is a pseudoscience. So we'll give reasons why the practice is a pseudoscience. People that are looking into this. And these pseudoscientists respond with excuses and attacks on us. Yeah? The idea is aimed directly to the public. Well, you see this, I'm not really up on this bit, because basically they've got confirmation bias anyway. So basically, it says scientific breakthroughs will normally have been published in science journals, scrutinised by other scientists, and only announced to the public once scientists have agreed that the scientific breakthrough is indeed genuine. But like I said, they've got confirmation bias anyway. They've got an agenda behind it, so they're not going to shift from their paradigm. They're scared to, basically, as well, because they're scared of losing their jobs if they say anything against what everyone else is saying. So that's not going to happen anyway. So that's like basically the peer review stuff. It's just a retort. They're not going to take anything different to what they're saying seriously. So I'll leave a link to this so you can read that bit. I don't want to have it too long. Ideas that are non-testable. A crucial problem with many pseudoscientific ideas is that they cannot be tested in any meaningful way. This can come about because what is being claimed is so nebulous and vague it is difficult to conceive of how one would test it. Also, such vagueness facilitates a legion of possible interpretations, when just about anything could be made to fit the outcome to support the original claim. If a claim or theory cannot be tested, then it cannot be falsified, and thus it violates a central principle of science, that of falsifiability. See Braithwaite 2006, Carroll 2004. If a theory cannot be falsified, then no evidence can be gleaned that would speak to the issue one way or the other. It is thus scientifically meaningless. Ideas that cannot be tested or are no more right than they are completely wrong. We've got all this outer space stuff that they're telling us we've got to believe and everything else. It can't be tested by anybody else, only these space agencies. So basically, can't be falsified. So it's pseudoscience. Verbose language and prose. One reason that theories from pseudoscience are vague and untestable is that the language used by the proponents is far too vacuous itself. This often results in an idea that is so conceptually slippery it becomes difficult to identify what is actually being argued, or how one might test it, due to their nebulous content. Such practices also nearly always hide all sorts of circular reasoning, errors, over-complex words, phrases, and overlong sentences are employed in an attempt to look scientific and intelligent. Indeed, in pseudoscience, the more scientific type language employed, the more plausible it appears to be. However, all this really accomplishes is confusion. This is why they've changed the meaning of these words, like the meaning of level, the meaning of theory, the meaning of Peter Peterson did a video. I've just watched it tonight, and there was on about the word boiling is when we get water and add heat to that, and it'll boil and evaporate. But when they put water in a vacuum, they call it boiling water in a vacuum. And they've got a video on their thing where they showed where basically it shows that the water's not boiling, it's just the air bubbling out of it because it's in a vacuum. The water's not boiling, because if it was boiling it'd be getting hot, but the temperature of the water stayed the same, or if anything dropped a bit, so it wasn't boiling. So they've changed the meaning of that word as well to fit. So it's just there, like it says here, just so confusion, and that's done by design, in my honest opinion. Poorly defined terms like energy, resonance, quantum, nano, dimensions are all used with no useful explicit definitions provided. They are meant to look scientific, to look respectable, in order to add weight to an idea which is in reality both implausible and improbable. Poor writing often reflects poor thought and poor understanding. Whenever one encounters flowery and verbose language, it is likely the authors or the speakers do not fully understand what they are talking about. Verbose language is used to fill in the gaps of knowledge by making it sound as if something profound and insightful is being said, when in fact the sentence rarely goes anywhere. Leave that bit. Confirmation bias. Many people report a common perception of thinking about someone when the phone rings and the caller is the person they were thinking of. Is this strong evidence for a psychic ability between these people? The answer is no. Of course it isn't. It reflects a selective bias in memory and reason. Although we can remember the instances when this does happen, as it can be striking, we rarely remember the instances when it is not the person we were thinking of. Our memory is biased to place an emphasis on the hits and ignore the misses. And like I said, I'll leave a link. You can read this bit later. And we've got metaphorical analogy driven thinking. I'm just going to, like I said, skip down to the bottom bit. Using anecdotes as evidence. So we seem to see that a lot. Lack of explicit mechanics. Special pleading, elusive evidence. And there's a bit about conspiracy theory. In summary, the defining feature of science is that hypotheses and ideas that are put forward must be capable of being tested and shown to be false, should they actually be so. This is the scientific criterion of falsifiability. As our examples above show, the telltale sign of pseudoscience is that the claims, ideas, or products are always pitched in a manner that leads them away from being testable and falsifiable. Pseudoscience then can be described as ideas, methodologies, or practices that claim to be scientific, but which are presented in such a manner that they cannot be tested or falsified by empirical testing. Like I said, I'll leave a link to this in the description. Thanks for listening.